Algebra 2 skills number 47, piecewise functions and graphs. What's a piecewise function? Piecewise function is a function that's defined by two or more functions or pieces that differ on different parts of the function's domains. Let's look at an example to clarify that. We typically have this one-sided brace for a piecewise function. There's different looks, but this is the most typical. And notice the color coding here. We use x minus 2 if our input value is 1 or smaller. We use 3x plus 5 if our input value is bigger than 1. You never use them both at the same time. You use one piece or the other if an input value goes with that piece. For example, if I'm trying to evaluate f of 0, notice the color coding. 0 is less than or equal to 1. Therefore, you use the red, but you ignore the green. So 0 minus 2, 0 replaces x in the red function, and I evaluate it. I don't worry about the green function at all because 0 does not apply to that piece of the domain. Similarly, part B, same function. If I evaluate 1, notice that again I use the red function because though 1 is the dividing point here, the or equal to option belongs to the red. So I put 1 where x is and I evaluate that. F of 1 is negative 1. And of course we could use the green, just depends on what you're asked. So if I ask 2, 2 is bigger than 1. So now we're going to use the green and we're going to ignore the red. So we put 2 in the x position for the green and we evaluate that. Now you could be asked to graph a piecewise function. You're going to see different techniques based on who you ask. I find this to be the best technique. Draw a vertical dashed line at any point where the domain divides. That could be one point, which is the most conventional, but it could be multiple points based on what you're working with. Okay, step 2 is evaluate the function at the dividing point for each neighboring function and plot either a closed if or equal to or open if not or equal to on the line. So we're going to evaluate each piece, even the piece it doesn't belong to, so that we can see kind of where it comes off of that dashed line. So we'll see an example in a minute to clarify. And then we're going to graph as many points as we need to on each side to graph the shapes on each side of that dashed line. So here's an example. This is almost the same function. We decided to change that to negative 1 just so that it'll be a little easier to see on the graph. So what we're going to do first is, there's my dashed line. We're going to put a vertical dashed line at 1. Okay, so there's the dividing point. There's only one of them here, 1. Sometimes you have 3 or 4 pieces and several dividing points. We're going to put a dashed line right there. Remember, when you dash something on a graph, that means that it's a sketching aid. It's not actually part of the graph. It's just there to help you see the graph. Okay, so I'm evaluating 1 into each piece. Even though the function's only defined for the red at 1, we're going to do it for both pieces here. Okay, so at the red one it's negative 1, and at the green one it's 2. If you put 1 in each position, and again, ordinarily f of 1 does not use the green, but we need it for the graph. Okay, so if you notice here, there's 1, negative 1 is right there, and we filled that in because it's the or equal to option. The green point, the 2, which is also on the dashed line, we don't fill that in. You can see it's open if you look carefully. That's because that there is no or equal to option. So remember, on the graph, when we shade things, we're saying that's the solution for the green line. That is not the solution there, but it's a point we need to help visualize it. So let's go from there. If we evaluate 0, now 0 is just the nearest point. You don't have to use 0, you could use anything, but 0 is close to 1, and we know that definitely belongs to the red. So f of 0 is negative 2 if you put 0 in here. If we go on the other side of 1 to 2, and we evaluate the function with the green at 2, we get 2 new points, 0, negative 2, and 2, 5. Okay, so I applied those points. 0, negative 2 is right here. That comes from this point. 0, negative 2. And then 2, 5, the green, 2, 5 is there. Notice that these are true points on the function. They are both solid. You will have no more than one open circle for each dash line you have. Anything that's not on a dash line is guaranteed to be solid. And the last thing you do is you just simply connect those. We know mathematically that these are linear functions, therefore we don't need an additional points here to help define the shape. We know that it is linear, and notice that we have to be careful. You're less than 1, so therefore the red goes on the left-hand side. You're greater than 1, and we know therefore that the green is on the right-hand side. Of course, the points guide that anyway, but it's important to note that greater than 1 on the right, less than or equal to 1 on the left.